right, hey guys, it's Mr. Kyle Myers Mathematics, and let's just jump into it. We're going to do the cone problem. So this is a problem for related rates, and the cone might look something like this. It can go this way, or it can actually be flipped around as well. But typically when I see these problems, you have a cone that looks like this, and you've got it dripping out at a particular rate, and we want to know what the rate is, either in the decrease of the radius or the decrease of the height as it's dripping and as it's at a certain point. So if water is steadily coming out of the cone, think like those little cones of water at dentists or doctors' offices, things like that. If there's a hole in the bottom and it's dripping, it's going to drip kind of slowly at first, and then it'll kind of speed up as it goes down because there's less and less of it as it comes down. So that rate is going to change over time. But let's say we have a cone that is, let's say 3 meters by 4 meters. So this is 4 meters. And it is dripping out. Cone, the cone, I'll write this one in print. The cone is dripping water at a rate of, and let's say, 1 meter cubed per minute. So we want to know what is the change in water level when the water level is, and let's say the water level is at 3 meters. If it's completely full, it would be 4 meters. So we'll say it's at 3 when it's at 3 meters. What is the change in water level when the water level is 3 meters? Okay, so in order to do this, I'm going to move this up. And if that water level is at 3 meters, then the actual water, if we isolate the actual water that's in the cone, then this would be 3 meters. And I'm just going to put 3 for the sake of just, I don't need the units because all the units are the same. The volume change is in meters cubed, and all the units are in meters, so we don't need to worry about the units, not until the end anyways. So that's 3. Um, we need to know what the radius will be. So there's a couple different ways to do this. This is kind of, we're going to get into the crux of this problem. I want to do this problem the normal way first, the way that I mostly see it done. And then I'm going to show you another way to do it that you either will like, or maybe you'll like the other way better. I don't know. But the point is that you'll have an option instead of just only knowing one way to do it. And that way, if you forget to do one of the steps to do it normally, you can still do it, and vice versa. So let's jump in. In order to get this to work, we need two formulas. So we need the volume of a cone formula, 1/3 capital B base times height. Capital B base would be the area of the base, and the base shape is a circle, so that area formula would be pi r squared times the height. But the problem with that formula is that it has two variables, well, three in altogether, three variables altogether, and I would have to do product rule. And we want to avoid doing product rule. So in order to avoid doing product rule, what we do is we set up a ratio. So we know that when it's completely full, then it has a ratio of 3 to 4. 3 for radius, 4 for height. So that ratio represents the ratio of the radius to the height. And if we multiply these out, we would get 3h is equal to 4r. And then we can solve for either r or h. We want to solve ultimately for the change in the water level. So we want h, which means that we need to solve for r. So it seems like it's kind of counterintuitive a little bit here, but we actually want to solve for r, because what that means is now when I go to plug that in, 1/3 times pi times r, which is 3/4 h squared times h. Now everything is in terms of h, and now I can take the derivative a lot easier. If I square this whole thing, those would be 3/4 h times 3/4 h. So that's going to be 1/3 times pi times 9/16, 3 times 3 and 4 times 4, and h squared and times an h. So I can continue to put this all together by saying volume is equal to, and I'm going to get the 9 and the 3 to cancel out a little bit here. So that would be 3 pi 16ths, 3 pi 16ths h cubed. Now I can take the derivative. So I take the derivative with respect to time, dv dt, and then the 3 pi 16ths is a coefficient. It's just going to ride along with the derivative. When I take the derivative of h cubed, it's going to be multiplied by the power and then power minus 1. So now that's going to be 3 times 3 is 9. So that's 9 pi 16ths h squared. And I forgot to put the dh dt. So let me squeeze that in there. I forgot to put that in there. 3h squared dh dt, because we're taking the derivative with respect to time. So h squared dh dt. Okie dokie. So we said that we want to know what's the change in water level when the water level is 3 meters. So the water level is 3 meters. We know dv dt as well, right? dv dt is 1. So the cone is dripping water at a rate of 1 meter cubed per minute. The reason why I know that's dv dt is because when you think about dv dt and what that means, it's the change in volume per change in time. Change in volume over change in time, or change in volume per amount of time. And that is what 1 meter cubed per minute is. Meters cubed is a volume, and then minutes is time. So dv dt is 1, and 1 is equal to 9 pi 16ths, and then h is 3, and then dh dt. And I can multiply both sides by, let's see, that would be 9, and 9 is 81. So I'd need to divide by 81 and pi, and I need to multiply by 16. And I need to do that on both sides, of course, to keep it even. So the 16s would cancel. 9 times 9, we do this in a different color. 9 times 9 is 81. So those would cancel there. And then the pi's cancel as well right here. So the pi cancels with the pi. And everything cancels except for dHdt. And so dHdt would just be equal to 16 over 81 pi, which you can write as a simplified decimal. It would be a pretty small decimal, but 16 over 81 pi probably would be fine for a final answer. And we need to include the units. It's going to be meters per minute. And that is our dHdt. So that's one way to do it. Remember, I mentioned that there's another way to do it. This is the standard way. This is the way that I've seen it done the most often out of all. The other way to do it involves using both the volume formulas together, pi r squared height, and then the other formula, 3h over 4 equals r. So you still have to use both formulas. But if you forget to use that other formula, you can just go ahead and take the derivative right off the bat. So dv dt, 1/3 pi. And then we'd have to do product rule. So left and right. So it's going to be left derivative right plus the right times the derivative of the left, which would be 2r dr dt. Okay, so that was a long derivative. There it is. And then the other derivative that we would need would be taking the derivative of both sides of this. So 3/4 dh dt is equal to dr dt. Take the derivative of that equation with respect to time as well. Then what we can do is we can say, okay, so dv dt, which actually we can go ahead and plug that in. So dv dt is 1, right? And then 1/3 pi. And then the radius. So we don't actually know what the radius is, but it would have to have that proportion to it. So if if r is 3 when h is 4, then r would be something when h is 3, and then I could just times both sides by 3. So r would be 9/4. So r is 9/4, and that of course is squared. And then dh dt is what we're solving for, plus the height, which we said we're looking for when the height is 3 meters. So we'd plug in 3 times 2 times the radius, which is 9/4, times dr dt, which dr dt is equal to 3/4 dh dt. Yikes. This is why this one is normally not the best way to do it. But if we continue here, we would say 1 is equal to, that'd be pi thirds. And eventually we're going to need to distribute that pi thirds. 9/4 squared would be 81/16. So let me blow this up a little bit. 9/4 squared is going to be 81/16. dh dt is what we're solving for. Plus, and then 3 times 2 is 6, but this is 2 over 4, so that simplifies that to 2. And then that would be 3 times 9 times 3. 9 times 3 is 27, times 3 is 81 over 8. And then that's dh dt, which actually I'm going to write it in blue as well, dh dt, just so that the dh dt's are both blue. Okay, so this is 81/16 and this is 81/8. I'm going to need to times that by 2 in order to add the fractions. So then that's going to be 81 plus 162, double 81, which is really just going to be 81 times 3. So that's going to be 8 and 6 make 14, 243. Sounds about right. 243 is actually a power of 3. So that's going to be 81 tripled. Yeah, so that makes sense. 81 tripled, because then that would still be a power of 3. So then that's going to be 243/16 dh dt. And then that's times by pi thirds. We can take it down a notch of powers of 3 and get that back to 81. That's still equal to 1. And then I would times both sides by 16 over 81 pi. 16 over 81 pi. And I believe that's what I did to get the answer earlier. So pi and pi cancels, 81 and 81 cancels. And the only thing I'm left with is dH dt, which, yeah, that's what we said it was. 16 over 81 pi. So 16 over 81 pi. So the way that it's normally done is typically the faster way to do it. Um, However, if you forget to consolidate the radius and the height, then what you end up having to do is this other method. So it's kind of like a backup method. If you forget to create that second equation, you're going to end up with some extra variables, dH dt and dr dt, and then h and r, that we really kind of need to use that separate equation for. So sometimes you just have to use more than one equation. This is kind of one of those problems where you just have to use more than one equation. You don't have to use them in only one specific way. There's more than one way to do the problem, and you get 16 over 81 pi either way. But typically the standard way to do it is the fastest way, but the other way is another way to do it. And it's a great way to check your work too. So if you are wondering if you got the right answer, rather than just going back and looking in to see if you got everything right just by checking each step, you could do it a different way and you should get the same answer. And that gives you more confidence in your work. So hopefully that's been helpful. And go ahead and check out the 5 math mistakes everyone makes and how to avoid them. It's a free PDF guide I have on my website, Myers Mathematics. So go check that out, and I'll catch you in the next video. Blessings, y'all.